Hey, welcome everyone into the Wells Tech Garage. Thanks for joining me today for today's class. Now guys, today is going to be a little bit different. Let's call it a little less structured, a little bit more fun. I'm hoping guys by the end of today's class, if you don't already use a lab scope consistently, I'll prove to you that you should be, okay? That's my goal here today is to show you guys a couple different case studies that the lab scope really help to diagnose when and where other shops have failed in their diagnosis or lack of diagnosis. So I'm hoping, like I said, at the end of this to persuade you guys into brushing the dust off the scope if you don't use it and get out and play with it. So why don't we jump right into this with the tech question. You guys will see that it's a little bit different today. This isn't going to really be a trivia question this time. It's going to be a little bit easier. All right, so as soon as we get that up on the screen. If you have a scope and don't use it at least once a week, why? Give me 3 reasons why you aren't using this tool consistently in your diagnosis. And if you have a scope and you use it at least once a week, why? Give me 3 examples of why you get your scope out when you're diagnosing. Now guys, only the first 10 emailed responses, you can leave it up on the screen actually, only the first 10 email responses will be eligible to win one of our shirts or our hats. And also, it'll be the first 10 email responses that come in after the end of the class, okay? So from the time that the class ends, the first 10 people to send me an email with either the first part of the question answered or the second part will win a hat or shirt. I want to know why you guys are using a scope or why you aren't using a scope, okay? And my email address is right here, okay? So make sure to send that out to me after the class ends. If I get it before the end of the class, and I know because I can see the time markers on the email, you will not qualify. But I don't want to leave it with just that because I want you guys to think a little bit. So I came up with this. This is a little bit of extra credit. If anybody can tell me what is unique about this, what this is, what kind of vehicle this is, you'll earn some extra credit and you'll be eligible to win a hat or a shirt, okay? So this is a relative compression test, right? We got peaks and valleys in our compression, and then we are back probed onto 2 coil trigger. Here's one and here's the other. But as you can tell, we are repeating these coils one after the other. Now, what's unique here, guys, is this vehicle that this graph is from has 4 coils, okay? I'm currently back probed into 2 of them, and they are firing on every other compression event. Okay, what is unique about this? What motor is this? What vehicle is this? Let's see if you guys can answer this little bit of a extra credit question, okay? All right, let's just take a quick peek at the comments because they were just roaring before. And right away I see from Eric in all caps, no pocket t-shirt, buyer beware. Eric, don't you call those rags, right? We do not have any pockets on our t-shirts. And also, guys, you can win either gray, blue, or black, or a hat. But like Eric said, there are no pockets on the t-shirts. Maybe the next order we'll get some pocketed shirts to hold onto your screwdrivers or magnets or whatever else you hold in there. Solid. Does the shirt have a pocket? Nice. What else we got here? Just want to keep up with you guys today. It wasn't supposed to be that easy. Lawnmower, motorcycle, okay. All right, t-shirts are great for cleaning up oil spills. Wonderful. All right, so first of all, guys, before we actually get into one of the 2 vehicles, we got a 2013 Dodge Dart here. That is pumpkin orange, as you can see, real pretty. And behind it there's an 07 Jeep Commander with the 4.7. Our little pumpkin here is the 2-liter in there. Before we get into those, I want to go over a little case study that was presented to me by one of our viewers who I believe is on here right now, Mike from Canada, sent me some information on a vehicle that he was working on. So let's bring that up here. And you guys can see here we have a 2004 Porsche Cayenne, however it's pronounced, 4.5 liter non-turbo engine. This thing was bought with 300,000 kilometers, which is like what, roughly 180,000 or so miles. The old mechanic special, new spark plugs, new coils. Seems to have a slight misfire, making some engine noise. It was picked up dirt cheap with the hopes of fixing it. So he sent me this video. This is some engine noise that he was dealing with on here. So that sounds lovely. This thing was throwing a consistent P0018 code. Now, if you guys watched our Toyota class, we were dealing with cam crank correlation codes on that Toyota, what was that, a 4Runner? So a P0018 is also a Bank 2 cam correlation code for this Porsche. So he was applying some of the lessons that he learned in that class to this vehicle. So I just have a couple pictures here that I want to bring up. Here's a picture of Mike in his Wells shirt with all of his scan equipment and tools ready to dig into this, this Porsche. I want to just note here, guys, see this right here? That's his scope, all right? I know that we show a lot of the picoscope. I know that we show a lot of using the snap-on tool or the launch tool or the Varus or whatever it may be, but I want you guys to know that when you're diagnosing your vehicles, you don't always need the most high-end of tools. Mike here is using a Handtech scope that I believe is only a couple $100. A real low-cost investment. You can pick up a used scope from AES Wave for relatively inexpensive. At the end of the day, we need to get the tools in our toolbox and use them. You don't have to, necessarily go for the master kit from Pico right away. Maybe graduate to that down the road once you've proven its worth to yourself. But, being able to start somewhere like this Handtech scope, he was able to diagnose this problem. So as we get into this, you can see he's ripped into it a little bit, and we're starting the diag. And first of all, we got some live data here. Actual angle for inlet camshaft bank 2, you can see we're sitting at a negative 64 degrees. So we definitely have a problem on bank 2. That's why our code P0018 is being thrown up consistently on this thing. All right. So he asked if I had any information on it, so I sent him a known good pattern that I just pulled off of IATN. And these are our cam sensors on this engine. All right, so we got a short tooth, a long breakdown here towards 0 volts, and then another short, and then long, long, okay? So this is a known good pattern for both bank 1 and bank 2. This is the pattern that Mike sent me for us to take a peek at. Ooh, we'll zoom it in here. And as you can see, yellow is going to be our bank 1, blue is going to be our bank 2. Yellow pretty much looks like what we saw on our known good, right? We got short, short, long, long, and if we go back here, we have short, short, long, long. So this is one camshaft revolution, another camshaft revolution, and our blue trace here, this is our problem child right here, right? We got a short pattern, but we're missing the rest. All right, and if we really zoom in on this, I would say that it looks like we're in time, right? We don't have a timing issue per se. We have some sort of signal issue here. What is causing this problem? We're missing our dropouts where the signal goes back to low. So at this point, I suggested to Mike to grab a borescope, pull out the cam sensor, which is on the back side of these motors, pull the cam sensor out and stick a borescope in there and take a look at what it looks like. Because something here is not giving us our proper signal. And he also mentioned that he swapped his cam sensors from side to side and the signal remained the same. So with a borescope on it, here we're looking at bank 2. This is our problem bank. You can see here's our long trigger point. As we're spinning this over, this is our long trigger. And then I'm going to just skip ahead a little bit here. Here's our other long trigger. So this is our long points right here. And then nothing. And if at first you don't know what you're exactly seeing here, maybe we should compare it to the known good side. So let's go ahead and turn this off. Let's go to bank 1. All right, so this is going to be the same thing. We'll skip ahead a little. We have our long trigger. Another long trigger. Whoa, right here. Look, our short trigger. And we should spin it a little more and we should see that again, right? 2 longs, 2 shorts. And there we go, another short trigger. All right, so when we're looking at our diagram here, what we're actually seeing is our missing short triggers, okay? So even though we have these trigger points on here, these long and shorts, it's the opposite of what you would think when you're looking at the scope. You're thinking short would be those 2 short triggers, but it's just the opposite. It's when it goes down to 0 volts that's when that metal is passing by our sensor, okay? So when that metal isn't passing by our sensor stays high voltage here. So when we have those long trigger points, those long sections of metal passing our sensor, that's when we sit low here. Then we have a short gap, and then we have our long trigger point again, and then we have a short gap, and then we have a short trigger piece here, goes back to long, back to short. We're missing those two trigger pieces on the crank sprocket or the trigger wheel or whatever you want to call it. So at this point, he's now verified the problem. He knows what's going on, so what's next? Teardown, right? So he started in on his teardown. Here you can see the front covers off of it. And here's what those 2 look like on bank 1. This is our good bank. Here's one trigger finger. Here's the other trigger finger. Here's the 2 long trigger fingers. Here's some oil that was, some metal that was in the motor. Here's our timing chain. You can see that they look to be about the same length. If they were perfect here, they would probably be about the same length. I would say they're probably about the same length. And then we have a couple quick videos that Mike was nice enough to send. So we have our long trigger point, and then boom, right here. See that? Broken. And right here. So I don't know what's caused this to be broken, and I don't know, Mike, if you figured out what has caused this problem, but that is physical damage inside of this thing. I mean, these are snapped off of here. For some reason on bank 2, they are snapped off and they are causing us our problems. And then here's our noise that the engine was making. This guide here was rattling back and forth. So, all right. So that's just a little case study that I wanted to share with you guys because I don't know, I guess I'm just really proud that a viewer took what we had showed from that Toyota class, applied it to a vehicle he was working on, and diagnosed a problem that had been sitting, and he picked it up super cheap because nobody else was willing to or could fix it or diagnose it. So, all right. Oh, okay. And yeah, asking about the oil pan being dropped yet. Thanks for the donations, guys, for a 2-pocketed T-shirt. I love it. We'll see about getting some pocketed T-shirts, maybe sometime down the road. We just put a new order in, so we got a lot of shirts here right now, but maybe next time. All right. And Eric's saying here, don't start the motor until you find those pieces. Definitely agree. You want to find those 2 chunks and make sure you get them out of there. Otherwise, they could cause some havoc down the road. All right. Now, let's talk about this Dodge Dart behind me here. This is a 2013 Dodge Dart 2-liter. I believe that's the first year of the Dodge Dart, right? Complaint is every 2 weeks-ish, give or take, this thing would do some weird stuff. The shifter, this is a floor shifter, the shifter would all light up red. Normally just the single gear that you're in would be red and the rest of the lights would be white. They would all light up red. When that happens, if you shift this thing down into reverse or into drive, it's a real harsh engage. It slams into gear. It doesn't do what it's supposed to do. Typically at that point, the customer would then pull off to the side of the road, shut the vehicle off, wait a few minutes, start it back up, and it's good to go. No issues found. This thing was originally brought in under warranty, had a reflash done on the TCM, and didn't fix the problem. The vehicle is now out of warranty, and the problem is still present. It still hasn't been fixed. All right, Bob's here. Just join in. Hey, Bob. Good to have you here. Sorry, lost my train of thought. Vehicle came in, and it's still not fixed. We need to be able to fix this thing. We can't just tell the customer that we can't fix it because we can't duplicate the concern, right? I have never seen this vehicle act up. I don't know. I'm basically going off of trusting the customer and what they're saying is a failure, and then looking for codes and that kind of thing. So if we can go ahead, turn the key on, and let's just do a quick code scan on this thing. All right. You think Mike's boss is reading this chat? Maybe. I don't know. He might be, might not be. All right, so on the scan tool, I already have a 2013 Dart loaded up. I'm just going to do a full system code scan, and let's take a look. Ignore the intake air temp circuit, guys. This was caused by me this morning when I took the airbox assembly off of here with the key on. So we'll let this thing run through the codes and take a peek at what we got. Do, 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 do. Keith, there's no sweating going on in here. We got the air conditioning working now, man. All right, let's scroll down, see what we got for codes. I'm going to bypass that one right there, guys, and I'll explain why in just a second. All right, here is the code that I first saw when I got into this car. A P1 Charlie 86-92, park reverse neutral drive low display or Prendl display, performance or incorrect operation as a stored code. All right, this is the only code that I had to deal with when I initially diagnosed this car, which was about a month ago or so. The car has not been fixed yet to this point. I wanted to fix it live today, but I did diagnose it and proved out what was wrong. So that's what we're going to do right now. We're just going to go through the process that I went through in diagnosing this thing. So I started out. Hey, Jim, somebody just donated $2 for the guy in the car. Thanks, guys. Jim appreciates that. Jim is in the car. Oh, you guys are good. All right, let's get into this code here. So we got a P1 Charlie 86-92. So we're just going to start looking up some code criteria. So let's do a P1 Charlie 86-92. Nothing. Still nothing. Okay? So apparently can't find it on Identifix. Let's go out to here. Let's grab our Dart. And let's see if we have it in here. P1 Charlie 86. And then we have our different code designations here, -92. So here we go. Prendl display, performance or incorrect operation. Here's a wiring diagram. Theory of operation. The gear shift module or electronic shift module performs various internal tests to verify proper operation. Okay, wonderful. We have a module for our shifter that's performing internal tests. This DTC indicates that there's an issue with the shifter's Prendl display operation or improper TRS messages from the TCM. Okay, meaning that this ESM module is receiving an improper message from our transmission control module about the TRS, which is transmission range sensor. So this is being monitored continuously with the ignition in the run position, and we set the code if the shift lever assembly controller confirms an invalid transmission range sensor message from the TCM. Okay, so right away we're talking about what here? We're talking about one module communicating with another module about a signal that's coming from our transmission range sensor. Possible causes, we could have transmission control module DTCs, improper TRS operation, transmission control module harness, or shifter lever assembly. Now guys, I do want to note, I want to pat whoever worked on this car previously on the back for not shotgunning parts at this thing. The only thing that was done with this was the module reflash on the TCM. This thing has not had any parts thrown at it. These things are kind of known for a lot of issues with modules. The transmission control module actually sits on the passenger footwell, right about where the passenger's wet boots are going to sit every winter, soaks through the carpet right on top of that transmission control module. So thankfully nobody shotgunned that part at it. This thing has had no parts thrown at it besides a reflash so far. So just keep that in mind. Now as we get down into the DTC checking, we talk about were there any stored or pending TCM codes. Now I briefed over that code before that was in the TCM because I did not have this to work with before, but I do now, so we might as well use it. If we look inside of our transmission control module on the scan tool here, we do have a P0705 stored in there, okay? So we know that we now have a transmission range sensor circuit issue going on, okay? Like I said, I didn't unfortunately have that to work with before. The way I made it to the transmission range switch was from in here. If there's display operation or improper TRS messages from the TCM, meaning we have a sensor sending a signal to the TCM, which then sends a signal to our ESM, okay? So what we can do is we can watch it on a scan tool, right? I mean, we have modules communicating, so let's see what the scan tool shows. So actually, I'm in engine right now, but let's go back. Oh, we don't need our keyboard. Let's go back to transmission. Let's just pull up some data. And let's grab shift lever position. And Jim, can you go ahead and shift this thing through the gears? Beautiful. Passes the test, we're done. Drive the car out, not acting up, we're done, right? Sure. Some shops do that, right? We got to find a way to diagnose this thing. We got to find a way to prove the failure. Now, sometimes, guys, you don't find all your information under the code criteria, right? You don't find all the information that you want in here. So what I like to do also is I like to actually look for the part. So we're going to go in here. I'm going to grab transmission and drivetrain. We're going to grab this. Let's grab our transmission position sensor. And they're nice enough to include a testing and inspection information here. Talks about how it provides data to our TCM. A bunch of other wording in here tells us how the circuit's going to function. And then it says here, continuity test. Using a suitable continuity tester or ohm meter test for continuity from pin 3 to each signal pins as the sensor is cycled to each shift position, okay? So according to the DTC conditions for a P1 Charlie, whatever that was, and a P0705, we're just supposed to look at the scan tool. All right, if the scan tool says it's okay, well then it must be okay. Now if we go into this, we're seeing that we're supposed to use an ohm meter. Okay, we can do that. We could hook an ohm meter up to it and see what it shows. If we were in a classroom right now, I'd ask you with a raise of your hand, who thinks that that's a good test? Who thinks it's a good test to put an ohm meter across the switch and take a look? All right. But because it's telling us to do that, why don't we go ahead and do that? So I'm going to first of all get some stuff out of the way here. Of course, that's not going to be the same size. I really like how these air boxes, or this whole plastic shield assembly here, it's really nice how that comes off. We got a clamp back here on the throttle body that happens to use a 7mm clamp on it, or maybe 1/4 inch, whatever it might be. And then over here on the actual airbox side, we're looking at an 8mm. Couldn't just stay consistent. All right, unplug the IAT. Again, this is where my code came from before. And let's pop this off of here and get this out of the way. All right, so I know it's going to be hard for you guys to see. We'll get to it in a little bit. But right down here, get my head out of the way, right down here is our transmission range sensor. So Jim, can you go ahead and turn the key off? What I'm going to do is I'm just going to start by grabbing some leads. And let's see what this looks like with it being ohmed out. Again, guys, if you don't have this kit from AES Wave, definitely check it out. It is awesome for lead sets, for some breakout leads. All right, so I'm going to unplug this, and what we're doing is we're just going to go right on the transmission range sensor side. Connector's unplugged, and all I'm going to do is I'm just going to ohm across this sensor. So I'm going to go from pin 3, maybe. All right, maybe that's on there. I can't tell. So already running into issues with, I don't know, is it connected, is it not? I can't see in there. It's kind of a pain to get to. But let's see what we got. I think you guys can already tell that I think this test is a little bit of a waste of time. So let's connect up our meter. I'll put this over here so you guys can see it. And now it's just a matter of hoping I find the right pin here, because again, I'm testing on a sensor that's bolted to the vehicle right now that I can't even see inside of the connector. So I'm just hoping to find the one. We are in park right now, correct? Yes. Okay, so we are currently in park. So I'm looking to find the part of the circuit here that is connecting us to park. We should see the meter drop out when we go to park. Okay? As you guys can tell, I'm having a hard time. There we go. We're in park. Woohoo! All right, so you can see the meter drops out. All right, let's go to reverse now. All right. Can you shift it into reverse? Yes, key on. And we should see our signal perfect. Our signal goes open because our computer or our range switch is no longer in reverse. So I'm going to grab another lead here and hope that I have the right pin for reverse. Hey, look at that. That was pretty good odds. I had a 1 in 6 shot that I was grabbing reverse. And all right, there's reverse. So continuity, a little bit higher in resistance this time, but still we have a connected circuit. As I'm wiggling this thing around trying to get a decent connection. There we go. So that's reverse. Beautiful. All right, let's go to, let's do neutral. I hope you guys are getting the point here that this takes way too much time. That's not neutral. Somewhere here. Maybe that's neutral? No, that can't be. Oh, that's why a pin fell out. All right, that's enough of that. I'm throwing in the towel. As you guys can tell, hooking an ohm meter up to this thing, what a pain to do, right? You got to try and figure out where you're connecting to. You can't see inside the connector. You could put a mirror in there, it might help a little bit. Let's scope it, right? Let's get our lab scope out and let's throw a scope on it and see exactly what it's doing. Our ohm meter, sure, it reads continuity across our circuit. Yeah, sorry, Jim, you can go ahead and put it back in park. It reads continuity across our circuit, wonderful. But that ohm meter is slow. Our computer reads that circuit a lot faster than that ohm meter is going to read it. We need to use a lab scope. Now, guys, one of the biggest complaints that I hear about reasons why people don't use their lab scope is that it takes forever to hook up. You know, it's covered in dust, the wires and leads are all tangled up. Guys, the key to using a lab scope is staying organized, right? Get yourself something like this. I picked this up at Harbor Freight. It was a couple bucks. It's just like a little tackle box. Organize all your leads, all your pins, all your back probes, everything in there. A couple bucks. You know, you can pick up containers or storage pieces for your scope. You know, not everybody's going to get the Pico box when they order their scope. You can get things like that at whatever local hardware store, whatever. Just keep your stuff organized so that every time you go back to it, it's really easy to get out and hook up. So I intentionally don't have anything out or hooked up today just because I want to show you guys how quickly we can get this thing figured out. All right, so we'll get the scope out. Now I've seen a lot of pictures of some pretty sweet scope carts and stuff set up. Maybe someday we'll have an awesome scope cart here, don't know. But you guys have made some pretty cool scope carts that make this even faster. Now I wrap my leads up every time, and just, again, keeping it organized, keeping everything from getting tangled with one another, because if it's a pain to use every time, and as I'm untangling leads, if it's a pain to use every time, you're not going to get it out and use it, right? You got to keep it organized, you got to keep it easy to use. All right, so I'm going to go ahead, I'm going to hook up all 4 channels here, because we're going to use all 4 channels. We're going to monitor park, reverse, neutral, and drive on the scope, and see what we can see. See if we can prove that this transmission range switch has failed and is an intermittent problem. Because right now, the car is just fine. It's got no issues. I drove it here this morning. No issues. No issues whatsoever. It hasn't acted up all week. All right? There's no rhyme or reason to why it acts up. Not temperature, not bumps, nothing. Completely random. Let's see what you guys are saying in the comments. All right, that's all set up. All right, let's see if I missed anything here. Keith says he screenshotted that picture for some Photoshop fun. Wonderful. Oh, Oh, it looks like Eric had to go. All right, let's see here. Yeah, saying nothing useful in comments. All right, let's get the scope turned on. And as that boots up, we'll start getting some things figured out here. I'm going to grab some back probes. And an alligator clip. All right, so where do we start? Well, we got to start with a wiring diagram, right? We got to figure out what is what. So if you guys are cool with this, we could use this. This is telling us what each pin number is supposed to do. So you can see pin 4 is supposed to be our reverse signal. Pin 3 is our power in. Pin 7 is neutral. Pin 8 is park. And pin 9 is drive. So if you guys are cool with that, you're more than welcome to use that. Otherwise, we will be looking at a wiring diagram. So typically, this is where I would go is I would find a wiring diagram for this thing. And you're left with this. And just because I was here before, I'm going to skip ahead right to the second one. And we can see here we have, here's 3 of our sense circuits, okay? T42, T3, and T41. But unfortunately, that doesn't say park, reverse, neutral, or drive. So it's not really telling us, and our other one is right down here. It's not really telling us what exactly we're looking for. Fortunately, if we go a different route, let's go P0705 because that was our other code. Fortunately, we do get some sort of an idea here. Here you can see our numbers again, T1, T3, T41, and 42. But if we scroll down through our charts right about here, you can see that in park position, T41 should be closed. So that means that we want to back probe onto T41 for our park circuit, T42 for our reverse circuit, T3 for neutral, and T1 for drive. Now I have another problem with this, and that is the fact that I have wire color labeled out here as T41 being yellow and black. Well, I know you guys can't see this connector down here. Well, maybe you can. I don't know. It's really probably hard for you guys to see. We might be able to see it once I get everything out of the way here. But I don't have a yellow and black wire in here, in this connector down here. Okay, so again, be careful with wiring diagrams. I'm going to go with trusting that pinout for back probing this thing, and hopefully we are correct. So I'm going to get back to that. That was underneath here. Automatic trans, position, testing. All right, so I'm going to go with this. So it tells me here I want to be back probing on pin 4 for our reverse signal. So I'm going to hook up the scope in the channel count just like it will be for the shifter. So channel 1 on our scope is going to be blue. Channel 2 on our scope, channel 1 on our scope is going to be blue. That's going to be park. Channel 2 red is reverse. Channel 3 green is going to be neutral. And channel 4 yellow is going to be drive. All right, so let's set that aside. If we can bump over to this overhead camera, we'll get some things back probed here. So it tells me, I'm going to start with park. It tells me that park is signal 8 or wire 8. So I'm going to go ahead and need a little bit more light in here. This is much easier to do with the connector unplugged. Be careful when you're back probing that you don't pierce the insulation or the weather pack on there. All right, then this is going to be, red is going to be our reverse signal. That's going to be pin 4. All right, doesn't feel like it went all the way in. There we go, pin 4. Bump over to green. Green is going to be neutral, which is pin 7. So I wonder, honestly guys, out of how many of you here right now, how many of you would have already put a transmission range sensor on this vehicle? Honestly. How many people, after seeing a P0705 code, seeing that the problem doesn't act up for 2 weeks at a time, how many people would have thrown a transmission range sensor at this vehicle for, let's say it costs $200, okay, for parts and labor? How many people would have done that already? Just curious. I'd like to honestly know. Because my next question is, what if it didn't fix it? What if 2 weeks down the road the problem's back? All right? How do you prove that what you've done and replaced a part, how do you prove to your customer that you changed something when you spent their money? Right? This is the problem that we have to deal with as technicians. We need to understand that we need to be proving out our failures before we go changing parts. We need to know that when we change a part, we're doing it for a good reason. And we need to have backup and proof of that reasoning. All right, so just get our last pin in here, maybe. I'm going to plug it in. Might be easier to get to that last one. Be careful if you guys are using T-pins, because if I was using T-pins on here right now, I probably would have just shorted some of my connections together. All right, these back probes work awesome. You could pierce the wiring potentially. I plan to do a video in the future showing the differences between piercing and probing, but that'll come at a future time. And for some reason, this does not want to plug back in. I suppose my head's right in the camera, right? There we go. If this was easy, everybody would do it, right? Jim, you sleeping in there? Make my head bounce off the off the hood. All right, I think all of our signals are now back probed. Let's throw a ground lead on this and let's see what it looks like on the scope. Okay, that looks good. Let's see what we got here. Let's turn our scope on. Let's start everything at 20. I'm thinking this is probably a 12 volt. Could be different, could be something different. Yellow seems high right now. Is the key on, Jim? Yes. Okay, key is on. I don't think yellow should be up there. I might have the wrong signal here because we should be in, are we in park? All right, let's try this. All right, what do we got? I want to see our blue up around that 12 volt line because right now we are in park, so we should be sending, oh wait, still not connected, right? Okay. Sorry guys, this is supposed to be going a lot smoother than this. Of course, it's got to be kicking my butt live on camera, as I'm trying to tell you guys how easy it is to scope this thing. Well, unplugging the connector and let's try this again. Still nothing. Let's try that. All right, so it's supposed to be pin 8 is going to be park. So second from the edge is park. All right, let's see how that looks. Really? Key is on? All right, can you shift it into reverse? All right, there's reverse. Neutral? Drive? All right, so blue is on drive right now. Blue and yellow both seem to be doing the same thing, which leads me to believe I got a bad connection here. Try this one more time onto park. All right, can you go back to park? I'm gonna grab a new back probe. This one is just beat up. And at this point is probably where you guys are saying that I should be probably piercing the wires, because at least then I know exactly what I'm doing. And I would probably have to agree at this point. It'd be easier. Hey, there we go. Okay. Let's make sure I'm not getting roasted in the comments quick. Okay, yes, Keith, you're right. Pierce it, right? All right. Hey, we're back. All right, so now you can see we have everything connected. Let's look at the scope, and you guys will see our 12-volt line high right here for park. Okay? Our other signals right here are all sitting right, well, let's get this one at 0 so they're all the same. Our other signals are all at 0 currently. I'm going to just up the time scale a little bit here and up our measuring. Now guys, this again is no different than a multimeter. We're looking at a multimeter that's being recorded right now. Let's keep with the scope on the screen. All we're doing is we're looking at a multimeter over 20 seconds of time right now on a scale that is reading from 0 to 20 volts, positive and negative, okay? It's just a multimeter. It's nothing to be scared of. There's a lot of buttons to push, a lot of things that we can change, but all we're doing is we're looking at voltage over time, okay? Very, very quickly. A lab scope can pick it up way faster than our multimeter, and that's why we use it. All right, so as soon as this refreshes, I'm going to have Jim cycle us through all the gears in just a second here. So we're on a fresh page. All right, Jim, go ahead. Go through the gears. Reverse, neutral, drive, neutral, reverse, back to park. Okay? So it looks like a mess right now. We don't really see, well, some of you who know what you're looking at might already see some issues. But what I see here is we sit 12 volts high for park, 12 volts high for reverse, 12 volts high for neutral, 12 volts high for drive, and then back to neutral, reverse, and park. Let's go one step further. Can we bring the scope up, or the scan tool up on the bottom of the screen? And let's just grab shift lever position. Let's graph that. All right. Sorry, not that PID. Let's Prindle display. Why is that not what I expected to see? Okay. Jim, can you do that again? All right. Maybe that's not the PID that I want. Let's look for SNA. I wonder if it's reading SNA because it's got codes in it. Shift lever fail status, fail not present, park switch closed, transmissions in neutral, present gear neutral, and you're in park right now, right? SNA. I wonder if that's because we unplugged it with the key on. All right, let's back out here. Let's just do a quick code clear. All right, I don't know what SNA means. That's interesting. I was assuming this should read park right now. We have the key on, right? Key on, we're in park. Okay. Well, anyways, let's go back to the scope because apparently the scan tool's not showing us what we want anyway. But go ahead and do the shift again. Okay, we'll leave it at that, and let's go ahead and zoom in. So here's our event, park to reverse to neutral to drive. Every time our signal goes high like this, we're in our other gear. Let's look at this right here. See how messy this is, guys? This is a signal that's coming out of our transmission range sensor. Okay, look at this. Right here. Is this not the same as telling the computer we are no longer in park? Let's back that up one step. We're sitting at 12 volts. The computer says, okay, I'm happy, we're in park. And boom, this thing's all of a sudden out of park. But it's not in reverse. Reverse doesn't happen until we're over here. Park comes up after. So we go into reverse, we're still in park. We have all of this noise in here. This does not look pretty. This is what we're using a lab scope for. This right here is seeing what we couldn't see with a scan tool, seeing what we couldn't see with an ohm meter. This is the reason we use a scope. We want to look for this noise, this dirty signal, this mess, because if this mess gets worse, this is where our problem happens. All right, let's look at our other positions. All right, these aren't as bad. A little bit messy in reverse, a little bit messy going into neutral, but not horrible. And let's look at drive. And that looks pretty good. Not too bad at all. So this is exactly why we need to be using a lab scope. Right here, this is evidence. This is proof, you guys, that this transmission range sensor in this thing is failing, right? It's not failing today. It's not failing right now. There's no codes in there right now that are present. The problem is not present. The shifter's not all lit up red. The transmission's not in limp mode right now. But under certain conditions, whatever they may be, this thing can act up. This is proof right here of a failure. What we want to do now, we want to change this thing out, and we want to take a look at what a known good looks like, right? Let's prove it out and re-verify afterwards. So Jim, you can go ahead and shut the key off. I already have a new part here. So why don't we just, I'm going to leave the scope leads hooked up to my connector, so hopefully all I'll have to do is plug it into the new one, get them out of the way so hopefully I don't disturb them. And hopefully all we'll do is connect to the new one and we'll be good. So let's go ahead and start ripping this apart. So we got to pull the battery out of here, pull the battery tray out. If we can go to the, there we go. Don't ask me why a Dodge Dart needs an Optima battery. Not my car. Let's see. I'm going to see if I can avoid disconnecting the PCM connectors. I might be able to just lay this back out of the way. Looks like I had a bolt down there. I wonder if we can move this whole box out of the way. What else is holding it in? All right, what are we missing? One more bolt? Yep. right, so our PCM is now loose. I wonder if we're better off just disconnecting our connectors. The key is off, right? All right, we'll just pull the connectors here. There's one. Two. And we got a ground wire, and then this thing will come out of here, and we will hopefully be able to see the range sensor. Set this paperweight off to the side. Don't drop it. It probably says right on there, drop if scrap, or scrap if dropped. And let's see. Something's still holding this thing on. Couldn't just be an easy one. Looks like we gotta. All right, let's take a look at some service info. Oh, it's bolted from the bottom. You gotta be kidding me. Oh, lovely. Let's go back here. 0.5 of an hour, half hour is what's quoted for this thing. And it's bolted from the bottom. And I don't think I can get to that bolt. You guys can probably see it now. If we take a look in here, maybe, right here, there's our transmission range sensor. I wonder if we can sneak this out without removing the battery tray. Let's get this sticker out of the way. Yeah, I think we can. Boy, it's going to be close. Of course, I don't have a 14mm short socket. So what I'm going to do now is I'm going to take the cable off the top of the. Of course, that's not going to fit. Well, if you had a shorty socket and a 1/4 inch, which apparently, unfortunately, I do not have, you'd be able to unbolt this thing and replace it. Unfortunately, guys, I don't know that I'm going to be able to replace this. Right? I don't want to give up yet. Let's try one more thing. I believe you're supposed to remove the battery tray to get this out, but I think we can do it without. All right, so I'm just breaking the nut loose that's holding our shifter cable to the top of our range switch. And this would be 100 times easier with the battery tray not in here. But again, you got to go through the wheel well to take a couple bolts out. And I just unhooked one of my scope leads. Well, if anything, guys, today I'm demonstrating the struggle of fixing cars. Now these switches are slotted. When you install them, here's a new one. Slotted for our bolt holes. Okay, this thing can move. All right, you can see when this thing was done by the factory, we got 2 black marks here on the white part in the center. That's what's actually going to be on the shift shaft that our cable is connected to. That's what's going to spin, okay? When we install this switch, this hole here is going to line up with our part of our shift cable, or our shift shaft, our shift cable. You're going to put a pin through there between the cable and the new switch. That will be done in neutral, and that's how you adjust it. So it should be just a matter of pulling these 2 10mm bolts out. And pulling our shift shaft off the top of the shaft in the transmission. And I also seem to be missing the short 10mm socket, because 10mm sockets never disappear, right? Have you guys been seeing those pop up around the Facebook groups and stuff lately of the 10mm sets with just about every 10mm socket imaginable? The swivel, the long, the short, the intermediate. Somebody was thinking, because those things just always disappear, right? All right, that one's loose. And now we should be able to pop this guy off. All right, before we do, I want Jim to put this thing in neutral. But guess what? You can't, because the battery's not in it. PCM's not hooked up. All right, we'll leave it in park for now until we get to the adjustment part of it. Should have left it in neutral before. And our new one. So here's our old one. If we can, here's our old one. I just wanted to note something that was interesting on this. You guys probably aren't going to be able to make out the logo, but the OE part right here, sitting on top of the OE transmission. 2 logos in there, both Korean, Hyundai Kia. Interesting little side note, Dodge Dart transmission is a Hyundai Kia 6-speed, okay? Just interesting side note, doesn't make a difference when you order parts for it. You're going to order parts for a Dodge Dart, but Hyundai Kia transmission in this thing. All right. So we'll set this down on here, and of course it's going to be off because we're not in neutral. I need to find a way to put this into neutral. All right, let's plug this back in. Here, let's put this back on here. I think I'm going to hook the battery back up, put the PCM back together real quick, and put this thing in neutral. Okay. Let's try putting this on the right way. Note, color-coded PCM connectors. And this ground is probably important, so I'm going to hook that up too before we turn the key on. So before you start this process, put the vehicle in neutral so you don't deal with what I'm dealing with right now. Alrighty, so we should be makeshift back together. Jim, can you go ahead and shift this thing into neutral for me? Alrighty, there we go. And just like I thought, our shift cable lines up with that hole in the switch. All right, our key off? Oh, that's right, can't key off. Kill the battery power, we'll leave it in neutral. Maybe slide this out of the way or not. Oh, that might work. We'll slide that out of the way. Here we go, a little time-saving tip. Well, I definitely am not making time on this job today. There's our old one. And our new one. And now what I'm going to use, guys, I got a little Allen wrench here. I'm just going to line up the two holes between the shift lever piece, or shift cable piece, and the new sensor. Make sure they're lined up as I tighten the bolts down. Because what that's going to do, that's going to line this thing up for the neutral position. And here I thought this was going to be easy. All right, so we're definitely in neutral. We're lined up. And now it's just a matter of getting everything tightened back down. All right, just about. Good. Tighten the cable back down on top of the switch, or on top of the lever that goes into the transmission. Okay. Plug it back in, and then we can start getting this thing back together. And I only lost one of my scope leads out of my connector. So I'm doing good. I'm going to hook the rest of this up after we're off of the camera, just to save you guys some time because I've struggled long enough on this. I just want to show you guys the results of this repair. So I'll put all the plastic back together later. Okay, let's see if we can get this one reconnected. And I think, oh, we lost the green trace too. All right, I think all our back probes should be back in. Let's take a look at our scope. Jim, can you key cycle this thing and put it back in park? Well, it starts. That's a good sign. Oh, we need a ground. Scope looks messy. There we go. What are we looking at here? All right, are we in park? All right, we're in park. Hang on, go back to park. All right, now we're in park. Blue trace is high at 12. Let's go reverse. Neutral. Drive. Park. Or sorry, back through the gears. We missed one signal in there, but that's okay. Keep going. All right, and just go through it quickly. All the way down, all the way back up. All right, so we definitely lost drive. Signal must have fallen out. But already you guys can see a huge difference, right? Square waves. Our patterns are nice and square here. We don't have all that noise. We don't have any issues where it's dropping out down to 0. I mean, here, I'll bring up my recording. I should have saved the one that we just had. So this is what we were looking at before, right? Messy signals all over the place. This is when I looked at it the first time. Red was park, but here's our messy signal between park and reverse. Here's our signal now. Perfectly square wave. So what do you guys think? Is this thing fixed? Is anybody still here after after all that struggling? Yeah, fun doing it live, right? Wonder if Scotty could have done this any quicker. Oh man, you guys are killing me. All right, bring this thing full circle. We started this class at 11 a.m. We went through a quick case study on the Porsche. So we took up maybe 10, 15 minutes in that. It is now 12:15. So Jim, you can shut the key off. Thank you. So we are an hour into this repair, right? We diagnosed the problem and fixed the problem in an hour. At the very least, fixed is fixed. And we'll be getting paid, what, an hour and a half for this job, right? Book time at a half hour plus an hour a diag. We're getting paid an hour and a half. We come out of this thing a half hour ahead. It probably would have been easier to put it up on the hoist, pull the battery cover off. I probably wouldn't be sweating right now. But yes, you're right, Keith. Jim's butt probably is asleep from sitting in that seat for the last hour and 15 minutes. But at the end of the day, we fixed it. I hope you guys, I wanted to show you the Jeep, but we're kind of running out of time here, and unfortunately the Jeep isn't acting up. It's one of those vehicles that had a problem about a month and a half ago. Do another one? Really? You want to see more? You guys want to hang out for more? I mean, if you guys want to hang out for more, I'll show you what's going on with that Jeep, or we can just about end it here. Okay, let's do the Jeep then. All right, so is everybody cool with this dodge dart. Everybody understand the reason why the lab scope helped us when other tools couldn't. The scan tool let us down. The ohm meter testing let us down. All right, you guys want more? Okay, so the Jeep isn't going to be as cool as I was hoping it would be. I'm just going to let you guys know that right away. Jim, if you could, you want to get the scan tool hooked up in there? Get that thing ready to rock. The Jeep originally came in with a P0124 throttle position code. This is a 4.7 liter in this thing, so it's the old school 3-wire throttle position, drive by cable, not drive by wire. This thing came in, it was kind of hesitating, the idle was kind of stumbling. She said it stalled out 1 or 2 times. So we took a peek at it, and it does not need a TIPM module, TIPM, totally integrated power module. It does not. This one just ended up being a bad throttle position sensor, and I'm going to say that right away because there's a couple different ways to get there. Now, we've all seen where you're supposed to sweep the TP with a meter, right? And it's supposed to, you're supposed to see it. Jim will have a beard now. Oh, you guys are killing me in the comments today. A Jeep will never be as cool as you think it will be. Nice. So if you sweep a throttle position sensor, you run it 0 to 100% throttle position, and you're looking at it with a meter, you're going to miss dropouts or spikes in the signal. You're going to miss it. It's just what's going to happen. A meter refreshes maybe, 4 times per second? Let's say it's 4 times per second. That means once every 250 milliseconds, that meter is refreshing, and that meter is giving us some sort of new number on there, okay? Just so you guys know, on a Jeep, yes, you could use min-max potentially if it's fast enough. But on a Jeep, this will set a code, a P0124, if you have a 5-degree change in under 7 milliseconds, okay? 7 milliseconds a time, if it notices more than a 5-degree change, it flags a P0124. Did notice his hair turned gray. Oh man, you guys are killing me in the comments today. Good stuff. So, I'm gonna go ahead and delete this off of here. Let's scope or scan tools hooked up. Yes? Yes? We're good? All right, let's get it pulled up on the scan tool. I doubt this thing's gonna have any codes in it, unfortunately. This is one that I fixed a couple weeks ago. Is the key on? Yes. Okay. Fixed it a couple weeks ago, put a new throttle position sensor in it. Put the old one back in a couple days ago trying to get the fault to reoccur for you guys, and unfortunately it hasn't reoccurred. A lot of times that is because the exact position that sensor is sitting in when it's bolted down. All right, so we got our commander. Let's just let's grab a code scan. Let's see what this thing comes up with. Good question, Keith. I don't know what the RMS on the Fluke 87 is. Can't be as fast as the scope, though. Needs a big hammer. Welcome from Scotland. Awesome. All right. So what do we got for codes? Look, another intake airtime sensor, circuit high. Go figure. Had that one unplugged. Sets a transmission code as well. Interesting. And gateway, ignition problem, transfer case issue. All right, this thing's got a bunch of codes. But we're not going to bother looking through them all right now because it doesn't have the throttle position code that it originally came in with. Originally, it did come in with a P0124 code where we then hooked up the scope. Do this with your hands behind your back. We then hooked up the scope to figure out what was going on with this thing. So that's what we're going to do, I guess, at this point. First of all, you could sweep it with a scan tool. So we could go like this. Grab data, grab throttle. And we could go here, we could go calculate it, we could go voltage. All right, Jim, can you go ahead and just go 0 to 100 on this thing slowly on the throttle? Yeah, I don't think that's going to happen, Keith. I heard that tool likes to tell you how to fix cars. All right, so you can see we don't have any dropouts, any spikes or anything that the scan tool is recording. If the scan tool was recording a dropout, that would be an extreme failure. You typically will never see it in the scan tool. Also with a meter, you'll typically not see it either. But let's just take a look at what we've got. So I'm going to hop over here to the Jeep. Let's rip the air intake off of this thing and see what we got. And then I think there's one 8mm back here on the throttle body. Oh, dropped the socket. Oh, didn't hit the floor. All right, we'll pull this off of here, and then we can see our throttle body. Throttle position sensor is right here. All right, so this is just your basic old throttle position sensor, 3 wires, power, ground, signal. We have an idle air control valve, and then of course we have a cable-driven throttle body. Now I do want to note one thing, guys, here. When you're looking at scan tool data on newer cars, 2013, and older cars, and 07 is really not older, but it is still cable-driven throttle. Remember when you're looking at your throttle position PID that you're going to see different values. This car right here is going to vary throttle position because it is drive-by-wire. It no longer has an idle air control valve, so you'll see your throttle position varied by the computer when you do things like turn the AC on. If the alternator is having to charge a lot, you'll see different throttle positions spit out in your PID data, where on a vehicle like this Jeep, you should typically see your throttle position right around that 0 or right at that 0 mark. Because the idle air control valve is doing all of that work, your throttle position is going to, your throttle plate is going to remain closed until you, the driver, steps on the gas pedal, okay? And you actually pull it open with the cable. So when this thing originally came in, I saw this throttle position PID right here. This was my first giveaway when this thing was failing and this thing was stumbling and stalling and surging. This PID right here was changing. At idle, all by itself, it was changing. And if we did this right now, Jim, can you go ahead and start this thing up? Obviously we get that sucking sound, but we don't have any changing in our throttle position because, again, this is all going to be cable driven. We'll see the variance in our IAC right here. Idle air control valve is going to change in pulse width, and this is what's letting our air into the motor depending on load of the engine. Oops. All right, so let's just get out of here. Oh, thanks for putting a hose on it. We don't need the alarm going off. Let's just grab these all again. All right, so at this point, let's shut it off and let's throw a lead in there. And let's take a look at this on a scope compared to a meter. Now, normally, guys, I would never recommend running 10-foot scope leads into another set of 10-foot scope leads across your shop to your vehicle. I'm doing that today because the scope and the scan tool and everything is already set up over here. So hopefully we won't run into any signal issues because of the extreme length of our cables here. But I'm just going to go ahead and I'm just going to grab one channel off of our scope. And I'm just going to piggyback it onto these other leads and hopefully have enough to reach all the way over here through 20 feet of cables. Again, don't do this if you're in the shop. It might mess with your signal strength or I mean, you're just going through more resistance, right? The longer the wire, the more resistance. And let's find a ground. Alternator bolt right here looks good. And then let's go one step further. Let's grab the meter. And our CO alarm is going off. Good to know that we are not going to die today from carbon monoxide. All right. So we got our meter hooked up. All right, Jim, do you have the key on right now? All right, so key is on. Can you guys see that? Maybe-ish. Let's put it right here. All right, so 0.5 volt. That's what we'd expect to see at key on. Let's take a look at what we're seeing on our scope right now. We should also see 0.5 volt. I'm going to go ahead and turn off our other channels. And I'm going to scale this down because we're working with a 5 volt signal. And let's look at the scope. We'll just have the scope up on the screen here. There we go. So we're sitting at 0.5 volt right now. All right, so we're going to start with the meter over here. And what I'm going to have Jim do is I'm just going to have him slowly cycle through the 0 to 100%. Go ahead. And obviously we should see our meter changing as we go through it. This would just be considered a sweep test, right? And wide open should be somewhere right about there, and then we start going back. All right, beautiful. And what that looked like on the scope was a nice and slow path. Exactly what you guys would probably expect to see, right? But what if you go fast? Jim, can you do the same thing quickly as we're looking at the, let's look at the meter. Do the same thing. Okay. So we're not seeing anything. Now, Keith brought up using min-max. We could try something like that. I guess I'm not sure why we would use min-max on this. I'm sure you have a reason. But what I do for throttle position is use the scope because we need to be able to see this thing fast. So if we look at the scope again, go ahead and sweep the throttle position. Go ahead whenever you're ready. Yep. There we go. And back. Unfortunately, like I said, this one's not dropping out at all right now. Go ahead and do it a couple more times. What we're looking for is just spots in here where our oh, here we go. Beautiful. All right, you can stop there. Right here. Right here's an issue in our signal, right? We would have never seen this on our meter. Our meter's not fast enough. This is a problem right here. Our voltage has changed. Now, our spec is in degrees. We would have to correlate that to voltage, but it's in a 7 millisecond window. So let's just see how fast these issues are coming up. So if that's considered our issue, I would say that's roughly right at that 7 millisecond mark. Right? So we have issues in this sensor. I'm glad we were able to at least see something here. Let's try it again, Jim. Let's see if we can get it to happen again, see if we can get some more signal issues. And unfortunately, we're not going to see anything else. Oh, there's something. When we were at wide open throttle, we dropped a little bit of signal there. So if you're looking for a bad throttle position sensor and you're looking at it on a scope like this, you're looking for signals to drop out. There we have a little bit there. All right, Jim, that's good. You can go ahead and shut the key off. I knew this one was going to be a little bit hit and miss on this Jeep, so I actually have another waveform here from a Town and Country that I was doing the fuel level sender on. This thing came in with an intermittent fuel level sender operation. It would read incorrectly intermittently, and as you guys can see, as we move the sender, as the tank is rocked, as the vehicle is rocked, we're dropping signal, or we're spiking signal. Either way, depending on if we're going high to low or low to high, however you want to look at it, our signal is not perfect. We have these issues in here, right here. So as our signal is ramping down by whatever, a tenth of a volt or whatever it might be, maybe it's 1%, whatever it might be, as we get down to here, all of a sudden we have a voltage spike here. The computer sees this spike, like if we're looking right here at this spike, it sees this spike as the same as whatever voltage is over here. Or let's go to this one here. So this spike right here is being seen as the same level of this. So if this spike is to last long enough, if it were to last long enough, this could then change our fuel gauge from, if it's actually empty or full, it could read half or vice versa. We're picking out these intermittent problems here. I never saw the fuel gauge act up on this one, but after scoping this is exactly what we're looking for, and this is proof of why this was changed out. I mean, look at these right here. Okay? This is what we're looking for intermittent signals. This is what we're looking for when we're diagnosing cars that don't act up. We're looking to pick these tiny, tiny little fragments out that can give us a story to our customer to say, hey, I can't make this thing act up. I can't duplicate it, but I don't want to turn you away. Here's proof why I think you should change your transmission range sensor, or why I think you should change your throttle position sensor. All right? This is our proof right here. We can document this. We can save this file so that if this problem were to come back, we can say, hey, here's the before and after. Our transmission range switch before was showing us very, very dirty signals between the park and reverse especially. Now it's clean. We fixed something, but without duplicating the problem, we don't know if we completely fixed the initial problem. This thing could still have issues, but now if the customer were to come back, we have ammunition, right? We have a way to cover ourselves. We can show them the before and after. We can show them that we fixed something, at least, right? It's all about having proof, being able to show what you've done, and being able to justify what you've done when you've spent your customer's money. So, unfortunately, the throttle position one didn't work out as cool as I had hoped it would, but I think you guys get the gist of it. We need to be using lab scopes in our diagnosis. It's going to be the only way that we can really figure out these intermittent, once every 2 week type of problems. If it's to the point where your throttle position is making this thing run bad and it's idling terrible and it comes in like that and it's happening right now, that's a relatively easy repair, right? I mean, it's not super difficult to repair. But what if this was a problem that happened once a week, once every 2 weeks? We need a way to look at that. We need a way to figure out what that is. Using the lab scope is what's going to do that. And it doesn't have to be the pico scope. You don't need to use this, okay? Use whatever scope you can get your hands on. Start small, work your way up. But I would be willing to bet before long you're going to want to be getting a pico scope either way, because honestly, this thing is probably the Cadillac of automotive scopes. So I think that's going to be about it, guys. Let's see who's still here. A lot of comments. I guess today in the video, guys, we kind of documented the struggle of fixing an inexpensive scope for a DIYer. I would say if you're looking for something to just start out, grab a single channel scope, grab that little U scope from AES Wave. I think it's what, $150, I think, just for the scope. You can get the basic kit for under $500. I might be wrong in the pricing. But just start with something. At least then you have a single channel. You can scope your throttle position sensor. You can see that over time. It's a small little screen, but it works. I mean, all we want to do is we want to look at that voltage over time. Keith's got a good point to use the reference ground because typically the ground is not, it's not a pure battery negative. It would be off of some sort of reference ground. So yes, that is a good point. If you want to know about a cheap, okay. Well, thanks, Keith, for helping these guys out. All right, I think that's going to be it, guys. I think I've taken enough time today and struggled enough on camera with this one, but I hope, fingers crossed, that at least I've persuaded some of you guys to at least brush the dust off your scope, get it out, use it, play with it, organize it, because that's going to be one of the key things. Organize your scope leads, organize your stuff so that every time you get it out, it's not a mess, and then chances are you'll use it more. Don't be afraid of it. If you have any questions, if you want to send me waveforms or diagrams, I'd be happy to look at them just like Mike did with his Porsche Cayenne. I like looking at this stuff and helping you guys out. So if you need help with something, IATN's a great reference. There's all kinds of Facebook technician groups out there that you guys can check out as well for help in there. So yeah, tap on it. Yeah, tap on that throttle position sensor. That was always a good test for those. All right, unless you guys had any other questions or comments, I'm going to read through these all at a later date and talk about them in the Tech Connect. I also am going to take that throttle position sensor that's on that Jeep right now. I'm going to cut it open somehow, and I'm going to throw it under the microscope so that we can take a look at it. In the Tech Connect video, I'll have hopefully some pretty cool close-up pictures for that. Other than that, guys, I think that's going to be it for the day. So thanks for watching. Thanks for sticking with me. I hope at the end of all of this, it's persuaded you at least to check out your lab scope and use it in your diagnosis. So, all right, my email's up on the screen. As of 12:36 Central Time, you guys can start emailing me with your answer to the question that came up at the beginning of the class of why you don't use a lab scope every day for your shot to win a t-shirt or a hat. So, all right, thanks again for watching, and we'll see you guys again next time in the Wells Tech Garage. Thank you, everyone.